We move from the module to the inverter, and we're happy to have with us now Huawei speaking. And on behalf of Huawei, we will have Thierry Pollet, who is the production solution architect at Huawei, and we will talk about an important topic about grid forming and other next-gen inverter functions for a smart grid. So, Thierry, floor is yours. Thierry.
Am I audible now?
Yes.
Hello? Okay, very good. And can you confirm that we have the presentation up on the screen?
Not yet, and we cannot see you yet. Now we see you, and so one after the other. And now, if you share. And coming. And here we go.
Very well, thank you. Thank you, Michael. You started off the conference with reflecting on a number of key trends in this industry. And I would like at the beginning of this session support these trends with a number of data points. Before I move to the key challenges in this market and how it can be resolved by adding flexibility to the system. In particular, I will focus on the role of battery in from a commercial and from a technical perspective in combining with utility scale PV systems. And I will also highlight what are the key technical features that are needed to be introduced in PV systems and battery systems, which are inverter-based systems, in order to be able to integrate them with the electrical system when we are going to dominance of renewable technology into the grid. Well, we started off with saying, look, we have a large amount of PV installed worldwide. Well, we have reached terawatt level installation of PV systems worldwide, with China alone accounting for about 50% of the installed capacity. And if we look at PV systems, about 55% of that is captured by utility PV. If we look at regions, in particular Europe, we have seen that European Union has over the last couple of years introduced a number of policy frameworks to support the build out of renewables. And with that policy support, with this public funding support, we have reached an installed base of renewables which exceeds already the conventional fossil fuel-based generation. And if you look at PV in itself, it is the largest contributor to renewable technology beyond that of wind. Renewable technology in itself has surpassed that of dispatchable renewable technology. Think of hydro. If we look at the European region, the amount share of utility PV is not like at worldwide level. It's about 39%, but it is expected to grow in the coming years. Now, if we are introducing these non-dispatchable renewables, these significantly impacts the dynamics of the markets, the merchant markets, as also Christian indicated. One of the effects is that while increasing this less controllable generation, in combination with the demand curves, it leads to a number of situations where over the day we may reach spot prices that are very low, close to zero, or even negative. And here I've indicated for 23 the overview in Europe of the number of hours per year where we have negative prices. We see that these number of prices over the years have been significantly increasing, and this phenomenon is further intensifying over the last years. Over the weekend, I looked at the results in the spot market for various countries for last year and for this year, and here you see the result. The hours for selected countries where we have 0 or negative prices. And they start to represent a significant part of the hours over the year where we target to get revenue on the spot market. And I've selected the countries Germany because it's the largest European PV market, Spain, a significant market for utility PV, and then Poland and Sweden because there were strong growing markets for utility PV last year. Another parameter that is relevant in this discussion is the capture rate for PV, or the capture ratio. And here also we see confirmed the trends that with increased installed capacity, the capture ratio for PV is having a downward trend. The PV capture ratio is the PV capture price normalized to the baseload prices in the market. And you see here that year on year for last months, the prices, the ratios have been dropping. So we have till now looked at the economic aspect of having an increase of renewable technology, PV in particular. And we have seen that there, the market players, the asset owners, when faced with negative of 0 prices, may want to start curtailing their generation. Now, there is also an aspect of technical curtailment or technical control of the energy that is dispatched on the grid. And this can be related to grid constraints. This can be that there are capacity limits between the source of generation and where are the centers of demand where it is consumed. Somebody brought up in the earlier sessions, the time it takes for getting permits requests can be extremely long, laying between 30 to 50 months, although there are some activation areas where the target is to reduce that significantly. And there may be a need for redispatching in an area, the energy flow over the grid. And all of this leads to some number of percent points drop of the revenue for PV generated energy. On the left-hand side, I've showed a curtailment curve, which corresponds to the curtailment of both wind and solar in Spain, a company, although known for observability of the grids and having measures in place to avoid curtailment. Even there, we see that curtailment takes place for wind-generated generation. Now, what could be the solutions to address these challenges? There are a number of them. So one of them, as I mentioned, was to improve observability. A second important element in the market is the need for flexibility. And this can be provided in various ways. One would be to control better the demand side. Another aspect is to build out infrastructure of storage, which is by design an infrastructure which permits flexibility in the markets. And these battery storage solutions can be either standalone or can be co-located. The co-located solutions, BESS plus PV, give a number of additional flexibility points while designing a generation asset. The purpose of the BESS from an economical point of view is to be able to introduce time shifting or generation shifting during the day. At the same time, it allows for bidding into a number of advanced grid supporting markets, being the ancillary services, or to participate to new type of ancillary services that are being created, like inertial support, power quality support, fast frequency reserves. So how has the battery build-out in Europe evolved over the last couple of years? Well, there is a kind of gold rush in Europe regarding the installation of large-scale battery systems. And here I have indicated the accumulated installed capacity, I have not differentiated between standalone and combined hybrid solutions. It is clear that last year the market has boomed. It has tripled as compared to the year before. And the number of connection requests in terms of capacity that are with the transmission operators is huge. So that means there is a strong pipeline for coming further installed BESS solutions. Now, we have talked about the markets, the merchant markets, and its effect on the markets. But there are also some technical system-related aspects when we move to a dominated solar-based mix of generation. Namely, the fact that we take away inertia that are typically provided by turbine-based, synchronous machine-based generation systems. And this was recognized very early on. And here you see a map which dates already for some time, produced by ENTSO-E about the inertia, that's the kinetic energy of the rotating mass of the generator divided by the power of the generator. It gives you an indication of how well a grid can sustain, from a frequency perspective, changes in demand and load. And you see that in some areas, this inertia becomes very low. And the consequence of that is that if you have a step in power unbalance, the grid's frequency is much more sensitive to this unbalance. And the frequency drops or increases very quickly. And that means that some additional measures have to be put in place in order to keep the grid at its nominal frequency. So this was one of the key triggers to start investigating on how these inverter-based technologies like PV and batteries have to be evolved in order to circumvent this behavior. For that, a number of studies have been built out, and it has come to a new standard, or about to be standard, on how generation is to be connected to the grid. The end devices, the generating units, PVs or batteries, are to be able to support the grid from various perspectives, not only from the frequency stability perspective, but also with respect to be able to cope with phase angle jumps, to be able to support the voltage in the grid, to be able to support resonance issues in the grid, so being able to remove or reduce frequency components that are not the nominal 50 Hertz frequency, and also how can these new systems support regeneration of the grid after collapse. These new standards will come in place in the coming months, and new systems will have to be compliant to this. In particular, these systems have to be able to support grid forming capabilities. How this is to be done and how certification is to be done is also specified in standards like test specifications and processes defined by the certification agencies on how to support a unit with grid forming capabilities. Now, if we bring this all together in a new system design, how does that reflect on the system design? Well, it means that we will come to systems that are hybrid systems, like indicated below. There is a PV plant, a PV array, which is connected to a converter system and then provides AC support to the grid, where at the same time, we will have battery support systems connecting to the same connection point. This is one possible design where the battery system and the PV system are connected at the high voltage AC side. We can have alternatives where the system would be connected to the medium voltage side, and this could result into an optimization of infrastructure, for example, reducing the number of transformer stations needed, but this must also be seen from a non-technical perspective. There may be reasons from a legal perspective or a contractual perspective or a policy perspective that may prevent this type of medium voltage AC connected hybrid solution. Now, if you look at those solutions, it is clear that those solutions must have as a table stake that they are safe and reliable, and the maturity of PV systems is evolving in such a way that it is addressing the key failure modes related to DC level faults, which are the most occurrent faults in such a PV system. Examples are the capability to detect a reverse connection or reverse flow or faults at the DC level, at the string level, so that the string can be disconnected. There is the capability to detect at MPPT level DC grounding issues, and the results of these new solutions allow that the systems become high available. At the battery system level, since this is a electrochemical technology into which large amounts of energy are stored, safety is extremely important. So that's a number one element for the design of these hybrid systems. And then, of course, the combined hybrid plant will support these advanced features for grid support technically, while at the same time, it may create opportunities for the customer in participating to grid supporting products in the merchant market. Finalizing, this is a slide which indicates on how the revenue streams for this hybrid PV BESS portfolio can be created. This can be in various ways. One increasingly relevant way is the access to the wholesale markets, in particular in mature markets, where the revenue streams out of multiple products on the market are combined to obtain the optimal revenue for these hybrid portfolios. So this concludes my overview and contribution to this conference.
Thanks, Thierry. When you talk about Huawei is a global market leader in inverters, and so since you talked also quite a bit about batteries, so how is that business for you in terms of products? You're also selling both combined hybrid products.
Yeah, so from the battery storage market perspective, Huawei is a leading player in 3 segments. So we are offering solutions, integrated solutions for both the residential, the industrial, and the utility scale battery storage, both as standalone as well as combined with PV deployments. My takeaway from the discussions with customers is that there is a fair amount of new projects of PV customers that are moving towards hybrid-based solutions. The key element of Huawei is to be able to deliver a generating plant at the point of connection, where we have pre-integrated the various subsystems, be it the battery, be it the converter, be it the transformer station, and the complete control for controlling the plant in one solution. The reason being that it is more cost efficient and also more safe and reliable. It has been shown that from a safety perspective, if one does not do the necessary pre-integration, then the plants are subject to higher likelihood of failure.
Okay, thanks a lot. I think there's a few questions in the chat. If you can answer, that would be nice. In any case, thanks a lot, Thierry, for your great presentation.
Many thanks.
Okay, cool.